morning, everyone. So a domain-specific language for open access users. So I had this a while on my mind whenever I work with people wanted to use open access. It was always obvious that people without a computer science background, especially layout engineers, have a hard time using open access. I mean, either they have to get familiar with the C++ API, which is impossible if you're not fluent in C++, or at least you have to know a scripting language. Either way, the idea was to come up with something super simple that everyone could use, and that's what this talk is about. Next slide. Okay, if you can read it if you want, but we can skip to the next slide. So for the outline of this talk, so I give a quick motivation. Then we talk about what actually a domain-specific language is, or we call it a DSL. And then why we want to use Ruby to write DSLs. Naturally, we have to talk about meta programming in Ruby because that is what enables us to build efficiently DSLs. I will give you an example implementation of the DSL I was dreaming up, and then some summary and an outlook. Okay, so as I said before, open access is for sure a super powerful C++ API to interact with your layout database or schematic or whatever you have in your EDA system. But using it efficiently requires for sure a computer science background. As I said, there is open access script or a script. At least you can get away then with just being familiar with Python, Ruby, Tcl, or Perl, which many users are. But also most people, if you're honest, what you're using from open access, you maybe use 100 of the 2000 classes. And then it's really hard because the documentation you find is primarily written for C++. So translating this to Ruby or any other scripting language is sometimes hard because it also sometimes behaves slightly different. And then you have to really dive into these classes to understand what's going on. So as I said, I wanted to propose a domain-specific language. And the idea behind this is to simplify, have a simplified pseudo language, which still does most of your common layout operations. And the key is to hide any kind of complex logic from open access. And that includes open and closing cells, concept of blocks, which no one who is just a layout engineer understands why there is a block in the hierarchy of a library and a cell, why is suddenly another hierarchy level, or dealing with technology, meaning the concept, how this is stored in a database between data types, data layers, layer names, layer numbers, and so forth. Complex operations like region queries, they are not trivial to implement. So it's almost an impossible task for just a layout engineer to do that. And then another super annoying concept, you have to think in database units instead of your user units. I want to think in micron and not in micron times 1,000 or 10,000 or whatever the recent technologies require. Okay, next slide. So domain-specific languages, by definition, it's a language which is focused on a specific domain. So they say it's a DSL is good as exactly one problem. And the syntax usually has a very distinct look. You differentiate typically between an internal and an external DSL, where an external DSL needs a dedicated parser. So it's very limited. It's just you decide to implement a certain language, but then it's just handling these keywords, right? It's more or less a language which is keyword driven instead of an internal language or an internal DSL where you put your DSL on top of a given language, meaning you can use still all constructs of that language in addition to the simplifying model on top of it. And in the Ruby world, there are lots of examples of DSLs like rake, which is the makefile approach from Ruby on steroids. or Ruby on Rails, very popular web front end, or RSpec for testing, and Sinatra. And if you look in the examples on the, let me see, can I use the mouse? No. The example on the right here, where you see, okay, this is standard Ruby, like a class, you derive it from active record migration, a method called up, but then comes something create table products. And create table is not Ruby. It's essentially a keyword which says, yeah, create a table called products and add into the table a name and description field. So it's kind of like a natural language, but it's still Ruby. It just doesn't look like Ruby anymore. Or in the case of Rake, in the example below, where you have these keywords description. Okay, this is how I call my task. And then you define a task banana and say, okay, eat more bananas. Right, so it's a very simplified way of doing things, dedicated things for some problem, to solve some problem in a way that you can easily read it. Okay, next slide. So using Ruby, again, I mentioned Ruby is really good at writing DSLs. And why? Because Ruby has a very flexible syntax. For instance, if you can write a method in Ruby with method, parenthesis open, argument, parenthesis close, but you can always also leave out the parenthesis part. So it gets a different look. So lazy people write it in the way without parentheses. Other people, for better understanding, do it with parentheses. Another big feature in Ruby is that everything is by design an object. I mean, even the floating number is an object, which enables you to play lots of tricks with extending classes of floating points and adding your own functionality and so forth. Ruby also provides, which has this very distinct advantage, so-called IRB, which is an interactive shell, meaning you can essentially try out code snippets and see what Ruby does. So you do not need to feed in always your Ruby code in form of a file and see then some error messages popping up. You can essentially go open a session and just type Ruby commands, and you see how Ruby interacts with that. And then the strongest point of Ruby is the so-called meta programming. And you have constructs like method missing. So you can catch if someone writes a function which doesn't exist, or a method which doesn't exist, and you can essentially catch that situation and create a method on the fly. Or a concept which is called monkey patching, where you can simply on the fly update existing classes with new functionality while you're writing and running code. Or you have self-modifying classes, and there are lots of concepts under this meta programming which are really powerful and make Ruby such an interesting and powerful language. Next slide. So as I mentioned in the beginning, hiding the ugly and simplify is what we want to try here. So another thing we try to do, instead of just having a simple syntax to do some operations, we want to hide all the complexity OpenAccess we have to deal with when we use OpenAccess, meaning the task line of opening a cell. If I would count the number of lines I need to open a cell, it can't be done with a single line, right? You have to essentially open the CDS-lib files. You have to navigate. I mean, I would guess 50, 60 lines of code are necessary if you do error checking and certain things. I mean, that's always code you have to write again and again and again. Or region queries, another great example that they are complex and you need to write a lot of code to just flatten a design. Once you have it, sure, it's easy, but you have to get there, right? For me, personally, the most annoying thing is just dealing with technologies, data types, layers, instead of natural things. Like I think in Metal 1, I don't think in layer number 43, data type 76. And as mentioned in the introduction, DBUs versus user units, also I want to think in micron and not in micron times 1,000. And sure, error handling. So making the syntax simple is the second task. And next slide. So how this could look, such a DSL, is something like this. I want to say, oh, Metal 1 should be everything which is called Metal 1 drawing. So I essentially build a string here which says the name of the layer and its purpose, and I define my metal 1 variable. Or metal 2 is metal 2 drawing, metal 3 drawing. And then I simply say my variable M1 and M2 is simply M1 and M2, right? Or I want to do a shrink M1 by 0.1 micron, or grow M3 on the top by 0.2 micron. So simple commands without which everyone or every layout engineer could easily understand, because you can have a manual with your 100 commands, and that's all you need. And you can be very efficient in modifying your layout, creating booleans, creating objects, and so forth, and any task you might need to do. And you don't need to deal with the technology by parsing essentially the technology file to get the translation between layer numbers and layer names and so forth. Simple, easy commands. Next slide. Okay, now let's have a deeper look in how such a thing works. So in the bottom, you see this little shell window. So you follow that along with what I'm saying point by point here. So to start the DSL, we use this, I called it OpenAccess DSL.rb. It's a little Ruby code, which is actually my DSL. I give it an option -d, which simply says, this is the design I want to use. And in this little example here, it's just a design with 3 rectangles, 2 in metal 1 and 1 in metal 2. There's another option -i, which is actually the interactive mode. So what will happen, I'm essentially open a shell, and the shell itself starts a GUI of your favorite EDA tool and shows you the design. So this view cell just opens the first design, you see it on the top, the first one on the top, which shows you 3 rectangles. Then if I type in my command to select a layer, which is this M1 metal 1 drawing, it will at the same time tell me, oh, it found two rectangles, and at the same time it highlights them for me. So you see the yellow boxes around the metal 1 objects. And if you type in then your command shrink metal 1 by 0.2 micron, it just does the same. It says, oh, it shrink 2 objects, and it does the shrinking for you by visually showing it. So that's the power of a shell, where you get real-time feedback of all your operations you do. And at the same time, the commands are super easy. You don't need to read a manual. You just have easy commands to modify your layout. Yeah, next slide. Let's dive a little bit deeper into this DSL. So what is actually M1 space and then in quotes metal 1 drawing in Ruby? Well, as I told you before, it's a method. It's a method M1, and I'm lazy, so I'm not writing the parentheses in this case, and it has an argument, which is a string called metal 1 drawing. But unfortunately, this M1 could be anything, right? It could be my name, Larg, or it could be any word you can imagine, right? Whatever the designer thinks it needs to name this. So the problem is this doesn't exist in Ruby, meaning automatically this method missing function, you would need to define that to define what actually M1 metal 1 drawing is. So on the right side, you see this function I defined, which would handle, so Ruby would essentially call that procedure or method missing with the symbol, which is metal 1, and the argument, in this case, the string metal 1 drawing. And then it would call something which I named this DSL accessor. And what this DSL accessor is, it's essentially another of this meta programming features of Ruby. I'm calling a class eval, which I give it a string, and the string is essentially dynamically defining a method calling M1, called M1. And if it has an argument, I return an instance variable called M1, and if this argument is defined, I essentially run a function called getFixSet of metal 1 drawing. And what this does under the hood is just opening the layout, flattening the layout, getting all objects in the layer M1 by essentially going into technology first, figuring out what metal 1 is and what the purpose drawing means in terms of data types and layer numbers. And so there's about 1,000 lines of code behind that all. And at the end, it returns you your Metal 1 objects. And Metal 1 objects are, in this case, just an OXPOP fix at 90 array. But it returns essentially a instance variable in Ruby of these objects. So you see, even though it looks super simple, of course, in the background, it does a lot of things for you, which the user doesn't need to worry about. Next slide. So as I said, unfortunately, M1 is an instance variable. So it's a little bit hard to interact with its DSL because everything you do with the DSL needs to be evaluated within the scope of the class, because otherwise these objects, like the instance variable M1, is not defined. So essentially you have to pretend your DSL lives inside that particular class. You cannot do anything outside. So what's happening essentially, for instance, if you load a file, and instead of me writing these commands in the shell, I could just give these 3 or 4 commands, write these in a text file, give the text file to my DSL, and the DSL interacts then with OpenAccess. But under the hood, again, what happens is that I throw these commands I'm writing in a file, I evaluate these in the context of the class, and this is why you have this instance eval method, where you give it essentially line by line, and everything will be evaluated in the context of that class. Okay. Next slide. The method you would use to interact with the interactive shell from Ruby is, I don't want to go too deep into that, but it's the same trick. You essentially hijack Ruby's interactive shell by defining the context in which the shell should evaluate your commands, and you give it essentially your DSL. If you would look through this line by line, you would see or recognize that I give the IRB essentially my class as its context, and every command I would type in the shell will be evaluated within the scope of that class. So that's a really neat trick where you can hijack essentially the interactive shell from Ruby to do whatever you want with it, and hijack it for, in this case, our DSL for some real-time feedback, how you interact with your OpenAccess code. Okay, next slide. Now, just if you're interested, how you do the live interaction with your EDA tool, that's of course depends a little bit on your EDA tool, but I would say, let me just go through one example here. So the user opens the interactive Ruby, and this Ruby shell will automatically start your EDA tool for you. And direct it to start an IPC process, so a process which actually starts a daemon. Now that EDA tool communicates with the intercommunication process, IPC process, through these file descriptors 3 and 4. And for you who are not familiar with that, under Unix, you have essentially 4 of these file descriptors. It's 0, 1, which is your standard in, standard error, your standard out, and standard error. And then 3 and 4, which some tools use, like this EDA tool uses it to communicate with these IPC processes. The problem why, so this daemon which gets started can now communicate with your EDA tool. And on the other side, it communicates via TCP/IP with Ruby itself. And the reason why I have to use this daemon in between is most tools like Ruby already use these file descriptors 3 and 4 for something else. So they are essentially blocked. I cannot use them directly. Or I have other C++ code where I use Qt, this GUI environment. It's the same thing. It uses 3 and 4 for some internal stuff, so you can't use it to talk to your EDA tool directly. So this is why you start this daemon. You send it essentially your commands via TCP/IP. It just relays the messages directly into your EDA tool. So you can say, hey, highlight this polygon, draw this polygon, drawing not, but highlight, or open the window, close the window. And the nice thing is this whole method is in a way, if you quit your interactive DSL shell, it just deletes or it cancels all the projects. So it will just shut down your EDA tool, it will shut down the daemon for you and so forth. Next slide. Okay, so the problem with the DSL, there are some limitations, of course, because the DSL might conflict with the Ruby internal syntax. So as an example, if I do something like metal1 and metal2 equals m1 and m2 metal drawing, meaning I have an m1 object there, but I want to do an AND operation with an object I create at the same time. The metal2 m2 is essentially my operation to create metal1 objects. And Ruby is smart in the sense of it recognizes that you do a Boolean operation. So it expects the rest to be sort of a Boolean operation too. And so it gives me an error saying it doesn't know what this is because it's not a Boolean. You have essentially M1 and M2 and a string. So there's a string doing nothing in this whole syntax you're giving it. Of course, you can fix it somehow by writing the correct syntax so that Ruby isn't confused. So you would give it M1 and M2 in parentheses, your metal1 drawing string. That, of course, will work. But if you are paid careful attention to my code, you will see there's a bug in my code because I'm highlighting the layer when I return essentially that object. The layer will return. This operation will return a 1, which is just a fixed num. So Ruby doesn't know how to do an AND operation with a fixed num. So if I would give it the correct return value, which is these M1 instance variable, then this works. So you have to be very careful what you write in your code, of course, but you can get it done. Okay, next slide. Okay, as I said before, since this is an internal DSL, of course, we have the entire scope of OSScript and OXPOP and everything Ruby we can do, right? We can do loops, iterators, conditionals. So if you are an advanced Ruby user, there's nothing forbids you from using Ruby as is. But if you are just someone who is a layout engineer or not necessarily has a background in a programming language, you don't need to, right? You use your commands to do your operations, but you don't need to use the full extent of Ruby. Like I can say, what is M1 class, right? I give it's a fix at 90, or I can use the actual resize command instead of my shrink command. But I would say M1 resize -100 instead of shrink M1 by 0.1 micron. So, or I say, what methods do I have available on my M1 object? And it gives you everything. So that's the good thing, or the beauty about using Ruby as essentially your platform for your DSL. It's not limited. Where you have, if you have an external DSL where you write a dedicated parser, you have to essentially build in your own language to make something like this happen. Okay, next slide. So summary. So I demonstrated a simple DSL for open access based on Ruby. It has an interactive mode as well as a file-based mode. It simplifies the idea is to simplify common layout tasks, meaning creating rectangles, moving rectangles, whatever you can think of, Boolean operations. There is no special background required. I mean, worst case, you have a little manual with 50 or 100 commands. It probably OpenAccess would really benefit from such an add-on because it would open the door to way more users in the industry because they suddenly have a super easy and even an interactive way of dealing with OpenAccess. It hides essentially all complex logic from OpenAccess, so no one needs to worry how to open a cell, saving cells, and so forth. So it has a very high level of abstraction. Okay. Next slide. Outlook. So I would like to propose an X2 workgroup for defining this DSL with all its commands. I mean, I did just some essentially prototype on playing around how this could look. It's a matter of a bigger audience, I think, to come up with meaningful commands and what's really useful. And this is for sure use case dependent. Everyone has different needs. So that would give us the opportunity to define essentially Boolean or create modify operation, export features, whatever you can dream into such a DSL, and then of course create such a DSL and have it as an extension. So if you are interested in participating, please send an email to Marshall. And I can also give you in the context of, for instance, this OS script or XPOP work group live demo, how this in reality looks and that it works. And then we go from there. Last slide, I think. Yeah, here's a nice reference. If you want to learn more about Ruby meta programming, there's a really nice book called Eloquent Ruby from Russ Olsen. I highly recommend that if you're new to meta programming. It will open your eyes. What's possible. Okay, thank you very much. Any questions?
Well, I'll jump in with my first point is it's not a question. This is just awesome work. Well done, Larg. Great.
Thanks.
And then the question is, did you get as far as considering how you'd handle exceptions, things like that? Yes,
I mean, I was thinking about that, but you can catch essentially any kind of error and make these errors more understandable. Like the errors I was showing are, that is one thing I don't like about Ruby, right? The cryptic error messages. So I think if you really implement such a DSL, you need to spend a lot of time making error messages understandable, and even built-in help. That's another thing. What you need, I think, where you simply say, "Oh, help," and you get all the commands, and then you say help shrink, and you get how to use shrink. And the good thing about the interactive mode, that allows you to really play with such a tool for people to getting familiar with it instead of using a 20-page manual or something. You just play with it and see what it does and get help on the fly.
Great, yeah. And I guess just thinking in terms of DSL, one that we're all pretty familiar with would be like Bash, for example.
Right.
So then in terms of export, you'd think naturally in terms of piping or like the greater than symbol to send your result out somewhere else, you know, to a file. You could reuse stuff that people are well familiar with. So that's why I think DSL approaches like this are really wonderful. Thank you very much.
Exactly, yeah. You can do all sorts of interesting things in this context. It just opens if you think about it, it really opens the door for adding a layer on top of OpenAccess to make it more usable for, I mean, almost anyone, right?
Great, thank you.
Yeah. So somebody was, I think, about to ask a question. Go ahead.
Yeah, I'll go quickly. Yeah, great job, Larg. I appreciated the presentation as well, and I hope that we can start an extension working group with even if just a few people are interested. Marshall, we should do that and try to be as open as possible. I would be interested in participating myself. Real quick, just a comment, kind of actually going off of the last comment. We did also do a DSL several years ago. And I believe actually in Ruby as well, if I recall correctly. But it also did the same thing, like where you said like LS, and it would show the shapes that are in there and so forth, and then you could CD into an instance or something like that. So it would be interesting to collaborate and see what we could come up with.
Right. That is one way to go, essentially the shell approach. I was thinking about what is the most common things people know, and you're right. It's either Unix commands where you do CD or LS. That is actually a good idea. The other one is most people are familiar with. I mean, I'm not allowed to say names, but engines which run DRC or something, right? They have typically a language everyone knows. So many commands are just known and easy. So you could kind of gear it towards that, or even a combination of both, right?
Right. Yeah, I think the beginning of your presentation showed some of the DCL looked like a bunch of derived layers in a very short syntax. That would definitely be a benefit to something like OXPOP.
Exactly.
Yeah, thanks.
And
anyway,
especially getting rid of kind of this DBU versus user unit.
Yes.
Right, because that's just annoying.
Yeah, great job. Thanks.
Yep.
Larg, question, an end user, say an layout engineer, how much familiarity do they need actually with Ruby in order to be able to take advantage of this?
As I said, you can use this without knowing anything about Ruby, because in what my commands were demonstrating essentially something which doesn't look like Ruby at all, right?
So they would just need to learn the top level DSL
exactly.
commands.
That's the idea, and that's the beauty. And if they want to essentially dive in deeper, they would get familiar with more operations. So let's say they want to do some iterators or loops or if else, right? They need to get familiar with the Ruby syntax, but they can. So it doesn't limit you. I mean, I could implement this whole thing in C++ with a parser, but then I'm very limited to just this syntax, right? Here I have the power of a full-blown programming language or scripting language under the hood, which I can actually use and interact with the same way.
Great. Thanks. Yeah, great job.
Thanks, Dr. Weiland.